Hi, today we carry on our study of sectors of circles. So previously, I'm going to assume that you've seen the video on arc length. We saw how to work out the formula for the arc length of a circle, and hence the perimeter of a circle if we wanted to. We then did what if I gave you the arc length and you had to work back to some other quantities. Well, today we're going to look at the area of a sector, so how much of the sector we actually have, not just the length here. And the first thing I want you to do is write down what you think the formula is, because it's very similar to the arc length. And like I said, I don't want you to just learn a formula. I want you to be able to sort of understand and obtain it from intuition as such. So have a go. Pause this video and write down what you think the answer is. Okay, you're back. Good. So answer is this. We know the full circle area is pi r squared, but we only want a fraction of a circle. We want x over 360 of it. So this is a formula that you learn through this intuition. You know your pi r squared, and then you know the fraction of a circle. If you see a sector, you can calculate the area of it. Okay, so when you're next having a slice of pizza, you can get your protractor out, measure the angle, measure the radius of it, and work out the area. Okay, and so the rest of today really is just doing a few examples, and it's going to be the same sort of thing. I might give you the angle and ask you for the area, or I might give you the area and ask you to work back from the angle. It gets a little bit more complicated, I'd say, than the arc length because we've got an r squared in there. We'll see that in a minute. Okay, example number 1. So we've got a sector with a radius of 7 and x is 65 degrees. We want to work out the area, so we're just going to do the area is 65 over 360 multiplied by pi times 7 squared. We'll try this with me. Like you might even just give this a go by yourselves before I even go through these examples. What I calculate it to be is 27.794. Round that to 3 significant figures, 27.8 centimeters squared. Example 1, done. Okay, slightly trickier question now. Find the angle marked x. So this is a sort of situation where you know the area and you have to work back to the angle, but it's the same idea. So this is why being able to rearrange equations is so important. Okay, so this time we have that the area, which is 12, is equal, so we've got r as 5, is equal to x divided by 360 multiplied by pi r squared, pi times 5 squared. And we're going to do exactly what we did for the arc length. We're going to multiply both sides by 360. 12 times 360 will equal x times 5 squared is 25, pi times 25 is 25 pi, x times 25 pi. And we're pretty much there. Not getting my calculator out yet. X equals 12 lots of 360 divided by 25 pi. Put that in your calculator. 12 times 360 divided by 25 pi. And we get 55.003 dot dot dot. Round that. Remember, every time I'm writing the answer more fully and then I'm rounding it. 55.0 degrees. Always put your symbol in. Okay, done. Very, very similar to the arc length. Okay, this one is just a little bit different because now I want to find r, and we're going to see how that makes it different. I know the arc length, it's 50. 50 equals 70 over 360. I know the angle this time, multiplied by pi r squared. Same thing, multiply by 360. This time it's going to equal 70 pi r r squared. Divide by 70 pi. (50 times 360 divided by 70 pi equals r squared. The only extra bit is that we know we've got r squared, so to work out what r is, I need to do the square roots of all of this. 50 times 360 over 70 pi, and we can just use our calculator at this point. You can press the square root button, you can press the fraction button, it deals with it. Press the pi button and you should get 9.0471 ... equals 9.05 centimeters. I've accept 9.1 as well, and that's it really. So all we're really doing is we've obtained another formula, but this time for the area. Same reasoning as before for the arc length. We can find arc lengths, we can find angles, we can find the radius if we need to. Okay, so what I'd like you to do is try some questions yourself. I don't mind if you kind of just do every other one. So the first question is like just finding areas 4 times, just getting you to use the formula. It does similar with the angle, it does similar with the radius. So just making sure you are happy with this. What I'd really like you to get onto is these challenge questions here. This question in particular is amazing. Okay, and hopefully you'll think so as well. So have a go at that one. I'm going to show you the answers to the first few questions. Okay, so I know there's extra question answers in here, but figure out the ones that you've done. Let me know if you disagree with any of them. If you've done the challenge questions, okay, then send your answers to me. Okay, good luck with it, and we'll move on to a related topic next time. Okay, thank you very much for watching.